Assalamualaikum and welcome to the video. Encik Mio Muhammad Jamahiri bin Mio Ramli here from Physics Unit KMPK. In this video, we are going to go through experiment 6, standing wave. What we hope you to get from this video is that you can appreciate the importance the practical session in facilitating your learning of physics, hence making the learning meaningful. Because some of the apparatus might be foreign for you, we introduce them in the video. Reading the procedure with no background knowledge could be intimidating. So, we go through the setup process for you and we hope the procedure will make more sense to you. We are not going through the procedure step by step, but rather we are giving you the overview of the experiment and the great tips to help you with the experiment. Make sure you have with you the lab manual and open them to page 24 on the experiment standing wave. And also, you are going to need your jotter to jot down information and tips as you go along with the video. Before going to the lab session, make sure you have the objective, a brief summary of the procedure, and the table for data collection ready in the jotter. You can also add sketch to procedure as a visual tool to help you with the procedure. It does not need to be perfect or beautiful. Just keep it loose. In this experiment, we are going to utilize this concept to look for the value mu, mass per unit length of copper wire, by manipulate the mass of the slotted mass and investigate standing waveform in stretched string. Check out figure 6.1 in the manual. Mark the position of two consecutive nodes with a wooden wedge and measure the length L. Frequency of the standing wave in string in relation with tension in the string is given by the equation F equal to 1 over 2L square root T over mu. Mu is the mass per unit length. When we square both sides of the equation and rearrange them, we get T equal to 4 mu F square L square. To see how the tension of the string affects the value of L, we will plot them in the graph. From the equation that we have established earlier, we can plot the tension against the length squared. If we compare the equation with the straight line equation, the tension will take the y-axis, the length squared will take the x-axis, and the value of C as 0. The graph should start at 0 and the graph is going to be a straight line graph. When plotting your graph, make sure that the graph occupies at least 80% of the graph paper. Coming back to the straight line equation, the gradient of the graph will be equal m equal 4 mu f square. Choose 2 points on the lines and draw a right angle triangle connecting the 2 points. Make sure the size of the triangle at least 50% from the size of the graph. The gradient of the line can be calculated using the equation m equal to y2 minus y1 over x2 minus x1. and the gradient of the graph will be 4 mu f square, rearrange the equation, you get mu equal to m over 4f square. Frequency of vibration in the string is 50 Hz. You are going to compare the value of mu with the value that you get from when you manually weigh the string and calculate mu using equation mu equal m over L. In the experiment, you are going to manipulate the mass of slotted mass and then record the length of 2 consecutive nodes. You can refer to the manual. Finally, before going to the apparatus and setup video, we are going to present you with the table for data collection. Repeat each set at least twice and find the average. Make sure to enter the uncertainty for your measurement in the measurement column. Make sure you write the calculated value of L square and T in standard form and write the exponential power in the bracket if present. Let's go to the apparatus and set up. In this experiment, we need a G-clamp, a pulley with clamp, a copper wire, hanger and slotted mass 20 grams, wooden wedge to mark the position two nodes, a pair of magnets with steel holder. Begin the experiment by measuring about 2 meters of copper wire. Fix the G-clamp to the table and then fix the pulley at the end of the table. The distance between them should be at least 1.5 meters. Tie the copper wire to the G-clamp. Run the copper line from the G-clamp to the pulley. Make sure the line is straight and level at the both ends. Make a knot at the end of the copper wire to hang the slotted mass. Connect crocodile clip to AC terminal of power supply. Set the voltage to 4 volts. Before connecting the power supply to the wire, remove the insulating layer to the copper wire. One close to the clamp and the other one to the pulley. Place the magnet between the copper wire, switch on the power supply, and you will observe the formation of standing wave in the wire. This is the node. You are going to measure the distance between two nodes. Place the wooden wedge at the nodes and measure the distance between them. Add mass and repeat the measurement. You are going to repeat the experiment for different masses.